All right, class. Wow. And still feeling a little sick. We're going to try and get through this. I'm not sure how much I'll be able to get done. If I don't finish this lesson today, guys, we will finish it up in the morning, okay? It is, right now, if you can tell, down here, 12:59 p.m., meaning I have 20 minutes before my next class rolls up in here, okay? So we'll try to get as much of this done and ask questions tomorrow if you need questions, okay? So we're going to start with 11.4, Inscribed Angles, and you should have the notes I gave you today. So some of it is already pre-done for you, okay? So the first question is, what's an inscribed angle? Now, you don't have too much space there, so if you can, I don't know, I'm going to try and squeeze mine in here as well, too, okay? So I'm going to say is, let me draw a picture right there. Oh, man, that's a horrible circle, isn't it? Okay, let me draw another circle one more time. Hold on. I'm going to freehand it, though. Okay, I'm going to draw a circle like that. And what I'm going to ask you to do is, it's saying an inscribed angle. And an inscribed angle basically is an angle whose vertex is on the actual circle. Remember the vertex of an angle? Like this is an angle over here that I just drew. Actually, you know what I need? I need to have a handout, don't I? I don't have a single handout here. Hands are usually really helpful. Let me pull out a hand real quick. What letter do I use? Letter D. Okay. All right, so remember the vertex of an angle is this right here, this point. Okay, so an inscribed angle is going to have an angle inside of this, but the vertex, which is this point right there, is going to be somewhere on the circle, and that's basically what an inscribed angle is. So if I was to draw an inscribed angle in here, you know, like here's an example. Okay, so the inscribed angle, there's the vertex right there at that point. So let's just call this maybe like ABC, or actually let's use different letters. I know I give you such a small space in your paper. That's fine, don't worry about it. I'm not going to write much. So I have XYZ. That's an inscribed angle, okay? Now, we're going to go ahead and say, let me just go ahead and label right here. So I'll say that angle XYZ is inscribed, okay? Just so you know. So that's what an inscribed angle is, that the vertex is on the actual circle. Now, arc DF, or actually, I'm sorry, arc XZ, so we'll say that XZ, the arc, put the little arc symbol, arc XZ is the intercepted arc. Okay, so we'll call this an intercepted arc. I'm just giving you some terms here because I may use these terms later on. So this one's intercepted. It's kind of like it was captured by this thing, so it's intercepted. Okay, so like for example, this inscribed angle basically intercepted this arc right here. Okay, so that's what we're talking about. And the book does use another word also too. They use the word subtends. So we can say that also, that XZ, that arc XZ subtends DE. I'm trying to make some room here too. I should have probably written it right there. Should have written this right there, right there, right there, and then the last part. We could say that arc XZ. Here's the word, subtends, and subtends just means that it's inside of this angle. Okay, so it's inside of angle XYZ. So subtends angle XYZ. So all it means is that this arc right here is inside or within this angle right here. So that's all it means. So because this thing is found inside of this angle, the angle lines, it's called that. They say that it subtends it. Okay, so just kind of be on the lookout for this word. Basically, inscribed, intercepted arc, or subtends are the main ones there. Okay, so here's the most important part though. That was vocabulary. I cut this, pasted this out of your textbook because this is really important. Actually, this is the most important thing you're probably of this whole lesson here. An inscribed angle. Okay, so Look what it says. The measure of an inscribed angle is half the measure of the intercepted arc. So here's what it's saying. The measure of this angle right here, let me actually zoom in on this thing so you can see a little better. Especially some of you that are working on your phone, which is fine. Actually, let me make a perfect square. That looked horrible. Oh wow, it stretched it out like a rectangle. That's weird. Okay, anyway, excuse me. Okay, you know what? I can't even point to it this way. Never mind. Let me take this away. Okay, back over here. So here's what it's saying. If I was to measure this angle right here with a protractor, this angle right here is, this little angle right here is half what this blue piece is right here. Okay, so for example, if this arc AC is 100, then angle ABC is 50. If arc AC is 200, actually that's ridiculous. It's 60, then this right here is 30. If this is 50, this is 25. If this is 70, this is 35. Okay, as long as it's inside of the circle. Here's another version. If this is 40, then that's 20. If this arc is 80, that's 40. That's all it means, okay? So here's how they write the formula. The formula that I kind of took out of here, and you should write down. So let's go ahead and write down. To find the measure of angle, we'll call this ABC. To find the measure of angle ABC, all it is half. I just told you it's half of the arc. So we're just going to do the half of arc AC. Okay? I just showed you right now how easy I was doing it. So you don't really need a formula, but just need to know that whatever length measure this arc is, it's half of this one. Okay? It's going to be half of that, which is going to be over here. So again, if this is 100, this is 50. If this is 60, this is 30. That's all it's saying, okay? That's super important. You got to remember that. Okay, we're going to need that for the rest of the chapter. We're going to need a lot of things. Okay, next thing, find each measure. So I want you to find the measure of angle PRU. PRU, okay? So if you can, I would try to do these on your own and then hit play to see if you guys get the right answers, okay? Because I know you're not just waiting for me to write down answers. Angle PRU is this one right here. And so the arc for this PU is 1/18. So I know that the angle PRU is going to be half of 1/18. And what's that going to be? Well, I know 120, half of that is 60. So I don't want 60, I need 59. So it's going to be 59 degrees. Okay? And I should write it neatly, shouldn't I? So let me do it this way. There you go. Okay, measure of arc, SP. Okay, that's this other part right here. So remember, now you do it backwards. If the angle is 27, then that means that the arc is going to be double. So double 27. That's a 4. 1 and 54 degrees. Okay, so I have 54 degrees for this one. So the measure of angle, I'm sorry, not angle, the measure of arc SP is 54 degrees. Okay? Again, that was pretty simple. Let's move on. Alright, I love this one. This was actually pretty neat. So here's a corollary. Okay, this goes back way back, I think chapters 2 or 3 when we're talking about corollaries. Basically, it's kind of like a theorem, right? It's just telling you something that's always true. Okay? So here's this corollary. It says, if an inscribed angle of a circle intercepts the same arc or are subtended by the same chord or arc, then the angles are congruent. Wow. That's like kind of tricky. All that stuff, really long, a lot of words. But here's what I need you to do. Why don't we write down, let's put down an arc. Let's draw an arc. We'll call this arc AB. Okay? So arc AB. Now, here's what this is saying. It's saying that if I draw an inscribed angle that touches at A and B, for example, let me just put a point over here. Let me draw an arc, an angle for this. So let's just call this point C. And let's go ahead and draw an inscribed angle here. So bam and bam. Okay, that one's done. Okay, so that one's done. So remember, this angle right here is half of whatever this is. So if this is, let's just say this is 60, this is going to be 30. Well, guess what happens? Here's what this is saying, the corollary is saying. Well, guess what happens if you have another one, if you have another point over here, let's call it letter D, and let's say we happen to draw another inscribed angle, but we use the same points A and B. So then what if I do this one and this one? Okay, so this angle right here, ADB, well, if this is still 60, then what's this one going to be? This one's going to be 30 also. Okay, that's what this is saying. So, and then what if I draw another one? What if I do an E? And what if I draw another angle from this one using the same AB? What if I had an angle from here to here? Well, again, what's the measure of this thing if this thing stays the same? If this is 60, then this one's also 30. So I could keep drawing all these angles in here. It could be all different letters or whatever, and they could still be going all to the A and to the B, and they're all going to be the same exact measure. I don't care where you put it, it's going to be the same measure. Because watch, I could even add another one over here, and then just draw those three. Don't draw this fourth one. I could draw one right here over here, and call this F. Draw a line right there, draw a line right there. And if I measure this one's going to be the same thing because it has the same arc over here. This is the arc that's subtended, that says right there, that is subtended. Let me put this on the top. An arc are subtended, remember, it just means that it's within the two lines of the angle. So AB, because this is still within the angle, and this is 60, for example, then that would be 30. And then this one again, if this is 60, this one is 30. If this one's 30, that one's 60. This one's 30, that one's 60, because they all go back to the same B and A, okay? So that's what this corollary says. Alright, let's take a look at this. I got to do one of these projects in middle school art when I was in middle school. We got to do a really neat yarn project, and I promise you, this is on one of my lists, because I thought it was really pretty neat. We'll see if we can get this one done, okay? This is on my list. Okay? But let's try and find out what the measure of angle DEC is. DEC. Oh, that one looks kind of tricky. DEC. Let me highlight it in green. DEC. I want that one. And it says, if the measure of arc AD is 86. So it's saying if this arc right here is 86, I need you to find out what the other one is. Okay. So here's my strategy. Now, if you think you can do this on your own, try it, please. Please pause it. Please try and do it on your own. That's the only way you guys are going to learn, okay? So if you're having problems, then you can take a look at the video. So look, if this arc right here is 86, then what's this one going to be over here? The angle B. Well, I don't want to call it angle B. I'll call it angle ABD. What's that one going to be? This is 86, and that one has to be half of it. So that's going to be 43. Okay, 43. So we're going to use 43. 43. Let's probably use a light color. Let me use a color. 43. Okay. So I have 60. They give me the 60. They give me it. Now I have a 43. And do you know how to find this missing one right here? I know you do. 60 plus 43. I have 103. And I need to minus that from 180 degrees. And that should be 70, what is it, 77? 77 degrees. No, wait, that's ridiculous. 67. Wait, not 67. Is it 77? Yeah, it is. Gosh, my brain's not working. 67. Okay. 67. No, oh my goodness gracious. I just finished saying, what is it? It's 77. Oh my gosh. Okay, this is 77. Okay, let me ask you this. What do you guys know about these type of special angles? Look, this one right here and the one directly across from it. What kind of angles are these? I hope you're telling me these are vertical angles. That's a really important theorem. Vertical angle theorem. So this is 77. This is 77. Okay? So angle DEC is is 77. Done. That was pretty easy, actually. Is there a way, there's tons of ways, actually. Is there a way to find out what measure of angle, I'm going to ask you to do this one too, because you should have some space in your paper. Can you find out what the measure of angle, we'll say ECD is? Go ahead and find that out. Okay, I'm going to actually ask you to figure that out. And I wonder if there's anything else you can figure out actually after this. 60. You should be able to figure. Oh, I'm going to pose a challenge for you. Can you? This is a little challenge one right here. Can you find out what the measure of angle BDC is? Actually, that's not even a challenge. No, that's not a challenge. Can you find out? Here's a challenge. Can you find out what arc BC is? There you go. 2 problems. Try and do this turn your own, okay? I'm not going to go over them right now. I'm moving on. Gotta move on. So if you got those problems, write them down, add them in somewhere in your notes. You should have room on there, right, for that? I'm pretty sure you do. Let me see. Yeah, you got plenty of room. I was taking a look at your notes. You got plenty of room. Okay. Next one. An inscribed angle. An inscribed angle subtends a semicircle if and only if the angle is a right angle. Okay? So here's what it's saying. Look at your picture. The only time an angle that's inside of a circle, the only time an angle is going to open up exactly 180 degrees right here, like and create an arc that's 180 degrees, is if that's 90 degrees. Okay? Does that make sense? Because remember, the angle that's here is going to be half of whatever the arc is. So clearly, the only time that's going to happen when this is 180 is when that is a perfect 90-degree angle. Okay? That's all it's saying. So you got to remember that. So understand then, again, one more time, because I was just looking at the other example. If you see a line that looks like it's the diameter because it's chopping the circle in half, then automatically you should know that that angle is 90. Okay? So remember that when we're doing this example right here. Example 1. Find the variables. Actually, there's 2 of those. It's not example 1. It's like 2, right? Okay, so look. See how this line right here? W and Y. See how this right here is going through the center, through the radius? I'm sorry, through the center right here. So this is your diameter, so that you know that this is going to be half a circle right here. Okay, and because this is half a circle, that's 180. How many degrees is this gonna be right here? I just told you, box. How many degrees is this gonna be right here? And I hope you're saying this is gonna be 90, Mr. Fellow, because 90 is half of 180, because this whole thing here is 180, okay? So I'm gonna write that down. 5a plus 20, well, that's gonna equal 90 degrees. You solve it, okay? That's you. Look at this one over here. Let's see. This looks a little tricky. Actually, no, look. What do you know about this angle? And look how they both touch at L and M, and now look at this one up here. This one goes straight down and touches at L, and this one touches at M. So what do you know about these angles up here, this one and this one, if they both hit the same arc over here? Are they going to be the same degrees? I hope you said they are. Okay, because they have the same arc over here. So because they touch over here the same arc, the same L and M, then that's the same, that's the same. And now if you don't remember why, then go back over here to this right here and rewind and listen to this one more time, okay? Otherwise, you should be able to solve this by saying that 5b minus 7 is equal to 36. And then you find out what b is, okay? I'm not going to solve that. That's up to you. You got to solve that one. All right, construction of a circle. I don't think you guys have room for that. Do you? No. Okay, I'm going to stop right there. I think I'm done. I'm down to the theorem one, and the last example, okay? So go ahead and finish up just those two problems that I just finished, and we'll stop right there, okay? Only because my bell is going to ring. I told you I only had 20 minutes. So we're going to stop right there, okay?